Welcome to the channel. A very exciting video today. JWST did in fact break the Big Bang. It did break cosmology. And don't worry, it was already broken before it got there. It just showed in clear detail. And really it comes down to this galaxy for me, another impossible galaxy. This is from Anton Petrov. He is a popular YouTuber who YouTubes about mainstream science. This galaxy is one of many that have been found too far away, okay? Way too far away and much too developed for what we can understand in our current scientific model. Dr. Becky is another popular YouTuber who keeps making videos year after year about the crisis in cosmology. And a new study just made the crisis in cosmology worse. This was some 3 months ago. JWST just made the crisis in cosmology worse. That is from a year ago. The crisis in cosmology continues, and it goes on and on and on, and they will not actually have the courage to look at their models. But we will today. We will today. And there is a solution.
Chris Lado, welcome to Lado Files.
Another one, new JWST images suggest our understanding of the cosmos is flawed. How many more of these articles do we need to see? Okay, how many more? How many more years do we need to see? If the result is correct, we might need new physics to explain the universe. It's not a might. It's not a might. We do need new physics. And we have the new physics. Okay, and how long has this been going on? How long has the crisis been going on? Well, let's look, okay? The Big Bang Theory, 97 years, okay? This is what they call problems, okay? This is what they call problems. They call them tensions in cosmology, major tensions in cosmology. So we've had serious problems with the Big Bang Theory for 97 years, 97 years. I think it's time to actually look at our assumptions. Dark matter, right? That invisible substance that we can't find. We've been looking for dark matter for 91 years, 91 years. And we'll talk about today the Hubble tension, another major issue this is the most precise data I could find was actually the Hubble tension along with dark energy. And I think that's been going on even longer than 26 years. Now, what does a tension actually mean? A tension means that your model is incorrect. Your model is incorrect. This goes to all the physicists out there. Please have the courage to look at your assumptions. Because what does this imply? What does this imply and point directly at? Your baseline assumptions are incorrect. Your baseline assumptions are incorrect. They keep saying we need a new theory. Dr. Becky keeps saying we need a new theory, and she seems excited about a new theory, but will not actually look at any new theories. And by new theory, we're going to show one today, and it's not new, okay? The theory I'm going to present today was actually the first idea by Einstein, the first idea by Albert Einstein. And by the way, he wasn't happy about quantum mechanics either, that other mess of a standard model that we have to deal with on a day-to-day basis. But it is changing, okay? And that's because we have unquestionable data from JWST. So thank you for being here. Thank you for having the courage to challenge your own assumptions. We can be wrong. All of us can be wrong and are wrong. Please hit the like button and share this with your astrophysicist friends or your physics friends who do have the courage to actually look at their baseline assumptions. And today we will show what's wrong, exactly why it's wrong. I'll show you 3 scientists using decentralized science, okay? 3 scientists who are actually looking at the problem and have presented what are viable alternatives. And today we'll show you what that new physics will be. And chances are you haven't heard of it before, even though Einstein spent over 10 years of his life actually talking about this theory. I bet you haven't heard it, but you will today. Let's get to the video. Okay, this is from the article, September 28th. The greatest puzzle in cosmology just got even more puzzling. Did it? It's been the same for 97 years. Images from the James Webb Space Telescope have confirmed that the universe appears to be expanding significantly faster than it should be. I'll show you today that's actually not the case. It is not expanding. Researchers report in a study accepted in the Astrophysical Journal, and this is probably the problem, the observation is in conflict with an esteemed theory, the standard model of cosmology that describes how the universe has evolved since the first moments after the Big Bang. After this video, show you The Big Bang did not happen. The conflict comes down to calculations of the Hubble constant, among other issues. Okay, I'll show you several issues. A number that describes how fast everything in the universe is flying apart. It's not flying apart. One calculation based on Planck satellite observations of the oldest light in the universe in conjunction with a standard model of cosmology suggests the Hubble constant is 67.4 kilometers per second per megaparsec. Is it though? Hubble telescope images of stars at various distances from us provide a fundamentally incompatible value, 73 kilometers per second per megaparsec, and it gets much worse than that. Okay, it's comical. Actually, it's comical. Okay, I showed how long we've been wrong. 97 years. The actual tension of the Big Bang. The Big Bang would actually be required for an expanding universe. Okay, that's how we get to the Big Bang, is that we have proof of expanding space, right? Which we've never found any actual data. There's no direct measurement of expanding space. So how wrong are we in other measurements? A lot. Very wrong. Okay. Dark matter is supposed to make up 26.8% of the universe. Again, we've never detected it because it's invisible. And dark energy. This is what's accelerating the universe. Okay. Dark energy is, again, we have never detected this. Okay. So what happens when you're 95% wrong? That means your baseline assumption is incorrect. Your baseline assumption is incorrect. This should be obvious. And why do you have to hear it from a YouTuber like me? Okay. There's other YouTubers, mainstream science YouTubers, because they're following the mainstream science. Ideas always come from the outside. We should be looking at our problems. Our tensions, these tensions that we call tensions, should give us the answers. They should lead us to our new theory, and they will. I'll show you right here. The new theory has already been developed. It's already been developed and presented by Einstein and rejected by mainstream science. Okay. Einstein did not come up with the expanding space idea, and he also did not like quantum mechanics. So I'll present 3 scientists today. Let's go to the first one. How could we be so wrong? How could we be so wrong? Let me show you a simple example of how wrong we are right now in our theoretical models. Okay, this is Sky Scholar.
He released a video a few days ago on coronal mass ejections and highlighted that for him, this was the strongest evidence for a liquid sun. Everyone needs to see that video. Of course, Unzicker is free to decide what is the most compelling evidence for a liquid sun in his.
Exactly. So Sky Scholar is Robitaille. He's one of the scientists who's actually making maverick type videos, okay, actually looking at fundamental physics. And what he's shown is that the sun is not a plasma, okay? It is not a gas. The sun is not a gas. That is the standard model, right? That all stars are gases. The standard model states that all stars out there are gases. They're plasmas, which is an ionized gas. But looking at our own sun now, we can actually look at it with advancements in telescopes. The sun is not a gas. It's obviously not a gas. And I'll just show you quickly. Okay, watch these videos, links in the description to get more ideas. Okay, this is just to show how wrong our current models are and can be. Okay, we can always be wrong. Looking back in history, that's always the case. It's always the case. And the Mavericks are always shot down and beaten by the mainstream science. Why? Because they look stupid. Yes, it's hard to be wrong, but you have to have the courage to look at your assumptions. Okay, so the first example is look at this actual videos from the sun, okay? A gas cannot move like this. Watch these sunspots as they hit, okay? As the sunspot shoots off of here, you're going to see. Look, that is a liquid. That is a liquid. That's condensed matter. Watch it hit. Another example. These are actually ripples on the sun. Okay, ripples in the sun. How are you going to get ripples like this in gas? In a gas. It's not. It's a liquid. It's a liquid. It's a weird liquid. It's called liquid metallic hydrogen. But that's what it is. It actually makes layers like graphite. Okay, how does a gas do that? A gas cannot do that. A gas can't do that. Here's one other example. And this is the strongest example for Robitaille.
Always be the thermal spectrum. This spectrum cannot be properly accounted for by gaseous plasmas, as I discussed last year in this video and addressed in depth in this paper.
Okay, look, this is actually the temperature of the sun, okay? We can measure the sun, and what it actually gives a profile. The temperature is down at 6,000 degrees Kelvin, okay? 6,000 degrees Kelvin. This is what a solid or liquid Okay, condensed matter makes a scale like this. If the sun was actually a plasma, it would be 150,000 degrees Kelvin. Okay, it just doesn't make sense. We should see discrete lines.
It can also not be accounted for by the electric plasma sun, despite claims to the contrary. The only feasible explanation is that the sun is condensed matter, as only condensed matter in the laboratory has ever produced such a spectrum. Again, whatever mechanism takes place in graphite and soot must also take place on the sun. The only option is the vibration of atomic nuclei within the confines of a lattice, as I have repeatedly stated. Mechanisms invoked in the Standard Model or for an electric sun have nothing whatsoever to do with the production of a blackbody radiation spectrum on Earth, and those are therefore scientifically invalid.
Exactly. So using actual science, okay, where you actually look at the science and you don't make up new models or invisible dark matter, invisible dark energy. Let's actually look at what we have. And what we have is the sun is not a gas. The sun is not a plasma. Okay, that's how wrong we are. Think about that. Think about that. Astrophysicists, when they look out at the cosmos, they assume that all those things out there that we're looking at that we call stars are plasma. They are incorrect. They can't even get right the sun, which is the closest star. It's amazing. So please go and look at Robitaille. He has some amazing physics, and he mentioned Unzicker there. And I'll cover Unzicker as the third actual scientist who comes up with the actual new physics, the new physics that will explain why we are not in an expanding universe, which again has never been detected. Okay, let's look now at what is the issue. We talked about Hubble's constant, the tension with Hubble's constant. So what is that? Hubble's law, also known as the Hubble-Lemaitre law, is the observation, okay, they say observation, physical cosmology, that galaxies are moving away from Earth at speeds proportional to their distance. Okay, are they? I'm going to argue in this video that they are not moving away. Okay, it's actually what we are seeing is a misunderstanding. They are not moving away from us. They are redshifted. In other words, the farther they are, the faster they are moving away from Earth. The velocity of the galaxies has been determined by their redshift. That is what we determine that the universe is expanding. A shift of the light they emit toward the red end of the visible spectrum. The discovery of Hubble's law is attributed to Edwin Hubble's work, published in 1929. Hubble's law is considered the first observational basis for the expansion of the universe. Okay, so this is where all of the incorrect assumptions come from, is that the universe is expanding based on this idea that all the galaxies away from us, since they are red-shifted, that's what that initial impossible galaxy I showed you at the beginning, it was way too far early formed. It was way too early formed for how the Big Bang should have occurred. And today, Hubble's law serves as one of the pieces of evidence most often cited in support of the Big Bang model. Okay, this is the Big Bang model, that everything occurred at some point. So let's look at Hubble's law. So the motion of astronomical objects due solely to this expansion is known as the Hubble flow. It is described by the equation V equals h constant times d is the distance, with h naught the constant of proportionality. So what they're saying is Hubble's constant. The big argument is the tension is that Hubble's constant, they can't find a constant. They can't get the actual number for it. Why? Because it's not a constant. The Hubble constant they call here between the proper distance d to a galaxy, which can change over time, and its speed of separation, the derivative of proper distance with respect to the time. The Hubble constant is most frequently quoted in kilometers per second per megaparsec, thus giving the speed in kilometers per second of a galaxy 1 megaparsec away. Its value is about 70 kilometers per second per megaparsec, so about 70 kilometers per second. However, crossing out units reveals that h naught is a unit of frequency. H naught is a unit of frequency, okay? So that means it's all based on the frequency shift, the change in frequency that we're seeing from light, from distant galaxies. And the reciprocal of the Hubble constant is known as the Hubble time. The Hubble constant can also be interpreted as the relative rate of expansion. In this form, the Hubble constant equals 7% per gigayear, meaning that at the current rate of expansion, it takes 1 billion years for an unbound structure to grow by 7%. So I mentioned at the beginning, I'm going to show you 3 scientists. I'm going to show you a second scientist who shows, again, there's many ways to show why this is incorrect. Okay, many ways. This is just one. Okay, according to the Hubble constant, something can only grow by 7% per billion years. So that's why you can't have these galaxies formed. These fully formed galaxies that the JWST is finding cannot be found. Why? Because they're growing faster than 7% a year. Is one reason. What's another reason we can rule this out? Check this out. This is the actual big ring.
Its diameter being 1.2 billion light years. And the radius of the circle that the giant arc is part of is about 5 billion light years. Well, did anyone make predictions of such objects on the basis of a non-Big Bang universe? Well, as a matter of fact, I did. In papers that I published back in 1986, 38 years ago, I used the simple assumptions that electromagnetism, plasma physics, and gravity operated on all scales in a universe that did not originate in a Big Bang. On that basis, I showed that primordial filaments, giant vortexes of plasma, should form and start contracting when they were 4.9 billion light years in radius, really close to the 5 billion light years of the giant arc. They would compress down to 1.2 billion light years in radius, again, really close to the 1.1 billion light year in radius of the big ring.
Okay, so that is Eric Lerner from LPPFusion, and he mentions his theory. Okay, watch this whole video. We'll explain it for you. Okay, he's not like arrogant or something. He's just saying it's a simple thing that he was able to do. This is the big ring, okay, that was recently found by a PhD student. Again, we just need new eyes on all these things, that found 1.1 billion light years across, and this is 5 billion light years across. Okay, but even this 1.1 billion light years across, there should be nothing this large in our universe based on the Big Bang. Why? Because it's 7% growth rate per year. You cannot get something this big. This should invalidate the Big Bang. This alone should invalidate the Big Bang, but it doesn't. Okay, the Boots void should invalidate the Big Bang. Can something that big have formed? No, not based on the Big Bang. So there are many, many things that should invalidate the Big Bang, but they just cannot look at their theory. They cannot look at their own assumptions. Okay, they don't have the courage to look at their own assumptions and call themselves wrong. That is the problem. But we will today. So what is the theory? The theory is variable speed of light. Variable speed of light. And this is what Einstein actually came up with, is a variable speed of light, is a feature of a family of hypotheses stating that the speed of light may in some way not be constant. No, it definitely isn't constant. We see it. Gravitational redshift proves that matter slows down light. For example, that it varies in space or time, or depending on frequency, like we mentioned, frequency. Accepted classical theories of physics, which are incorrect, and in particular, general relativity. Again, Einstein, this was his idea, was variable speed of light with general relativity. Predict a constant speed of light. This is incorrect, okay? They don't predict a constant speed of light. Einstein's first general relativity from 1907, for at least 10 years, was variable speed of light. In some situations, these predict apparent variations of the speed of light depending on frame of reference, okay? That's what he said. It depends on your frame of reference, yes? But this article does not refer to this as a variable speed of light. Various alternative theories of gravitation and cosmology, meta and non-mainstream, incorporate variations in the local speed of light. Mention one. Okay, we will cover. Attempts to incorporate a variable speed of light into physics were made by Robert Dicke in 1957. He did a great job of it, as shown by Unzicker. Variable speed of light should not be confused with faster than light theories. So here we go. Historical proposals. Einstein actually proposed variable speed of light with his first introduction of general relativity. Einstein's equivalence principle, on which general relativity is founded, requires that in any local freely falling reference frame, the speed of light is always the same. This is not correct, okay? This is why you can't do science directly from Wikipedia, okay? Let's look at the equivalence principle, because this does make sense. This is the actual equivalence principle, okay? Einstein said the equivalence principle is the hypothesis that the observed equivalence of gravitation and inertial mass is a consequence of nature. So that means that whether you are accelerating out in a spaceship or near a planet, it is equivalent, okay? That means gravity is related to inertia. You cannot tell if you're in an inertial frame. If you jump off a building, immediately, instantaneously, gravity goes away. And this was the shape of space-time. This is where we got to a shape of space-time, okay? But this is what I just read to you, where they state that the equivalence principle is that speed of light is constant, is just not correct. Okay, this is incorrect assumption. The equivalence principle states that gravity and inertial mass are the same, meaning if you're accelerating out in space, if you're in the ISS and you're accelerating at 1g, you will not be able to tell at all any difference whether you are on the ground at 1 gravity. It will be exactly the same, and it is the same. This is the point of the equivalence principle. Shown again here, inertial mass times acceleration, okay, so you flying at 1g, and gravitational mass times the intensity of the gravitational field are exactly the same. This means inertia, and gravity should be related. They're equivalent. That is the equivalence principle, okay? And this is his general relativity shape of space-time. And you see here, this is a little cosmological constant, okay? That's what he states, the cosmological constant. So let's look at the actual Hubble tension. So these are the redshift velocities, okay? So the redshift velocities based on the distance. So the further away we look, the faster stuff is going, right? That's the assumption we're making. Oh my God. Ugh. The reason they can't look and change their mind is because it's so simple that they want to slap themselves, okay? And they should slap themselves, and we should all slap ourselves. When we can't look at our base assumptions and change our minds, we should all slap ourselves. And please go slap the nearest astrophysicist for me. So here you go, okay? The further away something is, the faster it is accelerating. This is where we're getting the expanding universe is expanding even faster than we thought. The further away we look, the faster things are going, of course, because the further away something is, the more it has been redshifted, the more it has slowed down in energy, okay? Slowed down in energy through a variable speed of light. And we will explain this, okay? We'll explain this better. But now let's just look at the scope of the problem, okay? And look at these estimates. This is how they're measuring it, right? And JWST just gave us much more accurate readings. And the readings didn't match anything else that we have. So let's look at our readings. Again, you're going to want to slap yourself when you see this, any astrophysicists out there. I love this, how much work they're doing on all this stuff. Look, it doesn't matter how smart you are, okay? If you start from the wrong location, you're going to get to a wrong answer. It doesn't matter how smart you are. If you start from a wrong assumption, you are going to get the wrong answer. Look at this. Hubble constant calculated using different survey methods, okay? Look how wrong this is, okay? But, oh, there's even a better graph. Okay, this is so awesome. I mean, look how much work has been done. How many billions and billions of dollars have been spent trying to track down the real Hubble constant, right? The real Hubble constant. Look how many more experiments do you need to know that you're wrong? How many more? Oh my God. I mean, really, how many more experiments do you need to know that you're wrong? Okay, so CMB, this is the newest ones, okay, with Planck. CMB without Planck. Okay, so again, and look at these error bars. I love the error bars just get really wide when they're like, oh yeah, that covers into that blue. Okay, this is called changing your data. Okay, where is integrity first in science? Okay, it's not there. Okay, let's look back down. CMB lensing. Okay, this is indirect. Okay, measurements of H naught. Now let's go to direct measurements. Oh, this is from our CFID variables, right? Supernovas. Okay. Oh, okay. That's wrong. They don't even concur with each other. Okay, here we go. More supernovas. Okay, those don't match. Oh, look at this error bar. Just happens to cover all the things we need. Oh, there we go. From masers. There we go. Tully-Fisher relation. Way off. H2 galaxies again. Lensing. Oh, good. So if we look at galactic lensing, like how many different ways do we need to test to understand that our assumption is incorrect? How many different ways? Oh my gosh. And it gets better. Okay. So here in time. Okay. And by the way, back in 1958, they said it's around 70. So they were right. We were right back in 1958. And now they didn't even include that on here. They should keep going back because you're going to see even more and more inaccurate data. Okay, so here we go, Hubble Space Telescope. And by the way, this is why the Hubble Space Telescope went up. Okay, it was to get an accurate reading of the Hubble constant so that we could actually determine when the Big Bang actually happened and get more data on it. Okay, but what happened there? Look, what does this show you? Okay, are our measurements really so wrong? Are our measuring devices so wrong? This is what they thought. Do we need to fix it? Look at the Chandra X-ray. Look, all the way up here, 88 kilometers per second, down to 68 kilometers per second. That is the error in the Chandra X-ray Observatory. Okay, and then as we go on, Planck, very accurate. Okay, down here. Oh, Planck 2015. Look, it doesn't even correspond. There's Planck 2018. Different. Oh, there's Planck again. Okay, what does this show you? It's not constant. It's not a constant. How many more tests do we need to do? JWST just made it even that much more clear, but it's not going to change anything because it was already extremely wrong. Okay, let's look here. Oh, this is awesome. I'm just going to play through here as we look. Okay, from 2023, look at the amount of science. Look at how many billions of dollars, how many thousands, millions of people have been trying to solve this problem, trying to find the Hubble constant, right? How many millions, thousands of people? It's a lot. I need to speed this up or we're not going to get through it. Look, 69.8. And look at the error bars. 73 plus or minus 1.3, 73.5 plus or minus 5.3. I love this one. Goes up plus 3.9, down 3.3. That's not even uncertainty. Let's look here. 67.4, 67.6, 75.8 plus 5.2 minus 4.9. How does that make any sense? 73.9 plus or minus 3. Okay, that's an uncertainty. Okay, you can't have, how do you have uncertainties different going in different directions? I'm sure I'll get an answer based on current cosmological ideas. But look, just going to leave it going. This is 2019 only. Just going back to 2019 and the discrepancies that we're finding in the Hubble constant. How many more years do we have to watch videos of crisis in cosmology? Well, there's no real crisis. Maybe there is a crisis. If only we could find a new theory. Only we could find a new physical theory. Man, it's so exciting. And don't say you're excited about finding a new theory, but then not actually go and consider any new theories, okay? A new theory means that you have to accept that your current theory is wrong. Okay, you have to accept your current theory is wrong. The Hubble constant is not a freaking constant. I don't know how else to say this. I just want to get them and just like slap them. It's not a constant. Look, mid 70s. It was 100 plus or minus 10. I love they were most accurate in 1958. Look, 1958. He's like, it's around 75. That's as accurate as you're going to get. It's not a constant. It changes. I just showed just through our measurements and then showed through what we're looking out in the sky. And we see something that's too big. The Big Bang does not bang. Okay, so what is the new theory that was not new, that's actually been worked out over the last 100 years? When did we go wrong? Just go back to when our first theory came out about 97 years ago. Okay, so let's look at that. In physics, in general relativity, gravitational redshift, known as Einstein shift in older literature, okay, we should be calling it Einstein shift, okay, is the phenomenon that electromagnetic waves or photons, okay, we don't know the difference, we still don't know what light is, traveling out of a gravitational well seem to lose energy. Look, they even put it in seem to lose energy. No, they do. It does lose energy. This loss of energy corresponds to a decrease in the wave frequency and increase in the wavelength, known more generally as a redshift. That's why we're seeing everything red, because it's slowed down. It's slowed down. And the opposite effect works, in which protons seem to gain energy when traveling into a gravitational well. It's known as gravitational blue shift, a type of blue shift, okay, where it goes the other direction. It goes towards the other direction, towards the blue. The effect was first described by Einstein in 1907. Yeah, in 1907. 8 years before his publication of the full theory of relativity, when his mind was changed by the sheep, by the mainstream scientists. Gravitational redshift can be interpreted as a consequence of the equivalence principle, that gravity and acceleration are equivalent, and the redshift is caused by the Doppler effect, or as a consequence of the mass-energy equivalence and conservation of energy. Falling photons gain energy. There you go. Though there are numerous subtleties that complicate a rigorous derivation. No, there aren't. Okay, that's it. This is all you need. This is all you need. And it's already been solved. It's already been solved. So how would this work? So Alexander Unzicker, he's the third scientist I'll mention, and I'm a huge fan of Unzicker. Thank you so much for showing this. He has a variable speed of light playlist. I've watched through all of these videos, so I'll just show a short section on how this will work. Okay, general relativity may be described as curved space. So we're saying space-time is curved, right? Although we can't measure it with a constant c, so c does not change, or flat space with a variable c, meaning c would change. So c, light, as it goes around a body, as we see through gravitational lensing, and Einstein predicted in 1907, would be bent. Okay, how is light bent? Okay, you can either change the shape of space-time, this idea no one can really grapple with, okay, or you just say that light is attracted to matter, that we have proven evidence for. We have proven evidence of gravitational redshift. That's actually how astronomers determine the mass of stars, is they use the gravitational redshift. So if you just assume flat space with a variable c, it does work. The math does actually work. He explains it here.
And it is just a matter of looking at things if you say it's a curved space with constant c, or it's a flat space with variable c. Of course, if you consider the latter possibility, then by definition, length and time scales change too, not only c. And now let's have a look to the classical tests. Perihelion shift, light deflection, and gravitational redshift, and Shapiro time delay. And I will visualize now what Robert Dicke in 1957 has proven and considered.
Okay, before he goes to Robert Dicke, so Robert Dicke solved Einstein's variable speed of light. Okay, Einstein had one key issue about understanding the wavelength and the frequency. How do they change? Okay, but Dicke solved it. He actually solved it in 1957. What does this show here? Classical tests. This means Dicke's solving of the variable speed of light theory, okay, explain Mercury's precession. It explains light deflection, okay? So this will actually explain how light is changed in speed, okay? If the wavelength is affected, it will curve, okay? This is how it curves, because the actual length of the light closer to the mass is shorter. That's how it works. Okay, and gravitational redshift. This is a proven fact. We've actually measured this on Earth. They've measured gravitational redshift, and this happens in every star, every light, everything that emits light has a redshift coming from it. Light leaving Earth is redshifted. Okay, and this also explains the Shapiro time delay. It basically explains all of the tests of general relativity. It matches the tests of general relativity. So here he explains how it works.
Shapiro time delay, and I will visualize now what Robert Dicke in 1957 has proven and considered here. So let's get back again to his paper. We have here the variable speed of light, index of refraction here, and of course, if you consider the index of refraction to be variable, you have this little change here would correspond to 2gm over rc squared. And of course, you have the formula c equals lambda and f, the wavelength and frequency. And that means if you change d, then you also have to change lambda and f. Dicke said, okay, let's assume the relative change of wavelength and frequency is of equal amount, and then that would be gm over rc squared. And then now let's consider the situation here. I call this factor now gm over rc squared was the relative change, plus 1 would be a factor yet the need for brevity. Let's call that alpha. And then just imagine you have a C star outside the gravitational field. And if you're close to a mass, say the sun, you have this lower speed of light, with, in this case, divided by alpha squared, alpha to the minus the second power, if you're close to the mass. And this applies to all what happens, all atoms in the gravitational field. And of course, the frequency is also lower by a factor alpha, and the wavelength is also smaller, also by a factor alpha, and together f times lambda gives a factor alpha squared lower for the speed of light in the gravitational field. But mind here the difference to propagating light, okay? What I was explaining is atoms at rest, and everything is influenced by that. Frequencies and length scales are lower. But if you have propagating light, of course, the frequency does not change, because that's the entire idea. As in classical optics, you have a propagating light wave and you have refraction at a water surface, so for example, but you don't want to change the frequency here, because it would be, there would be a discontinuity here. So propagating light always has to keep its frequency in a static gravitational field, what we are going to assume here. And so the wavelength accordingly takes all the change here, okay? So this is important to understand the following. So let's look at light deflection, one classical test here. We just consider light passing nearby, so the wavelength is reduced, okay? And accordingly, you have this light deflection, which is observed for the first time in 1919. And you get this result of 1.75 arc seconds if the light ray is bypassing the sun. Another effect is the gravitational redshift, and it's the famous, Pound-Rebka experiment. Rudolf Mössbauer got the Nobel Prize in 1961. And again, think about here, in the gravitational wave, we have a lower wavelength, a lower frequency, and both contribute to, so to speak, double lower speed of light. But propagating light, which is, so to speak, falling into the gravitational field, it maintains its frequency. That means it has a higher frequency respect to the local ones, and that's what you observe, okay? A photon, if you imagine it like that, falling into a gravitational field gets more energy and has a lower frequency. And of course, if propagating light takes all the change, shifts all the change into the wavelength, then you have a lower wavelength with respect to the local atoms here, and that's compatible with what we stated before. So we have the gravitational redshift explained here, and we have also the Shapiro time delay conveniently explained. By this, it's just a double decrease of the speed of light in the gravitational field, and that accounts for the observed delay. And well, then there is one test left. It's a second order effect of the perihelion redshift. And as I mentioned, several other people have done this. There is one very interesting paper in 1960 by a group of German physicists, and they calculated by using this variable speed of light approach also the correct perihelion approach. However, I will do another video about the perihelion.
Okay, so Unzicker there casually explains variable speed of light and how it would literally link to general relativity. It makes sense, and all of our current ideas of general relativity. It says here is you have speed of light, wavelength, and frequency. Those are going to change depending on the actual geometries. E equals mc squared will yield a potential of 1/4 c squared, which is amazing. I asked Unzicker to consider, whereas if matter could actually just be light, trapped light, if you will, circling. So when propagating light goes 4 spaces, matter would actually go into the same location, right? So that would give you a 1/4. So if Unzicker does watch this, I hope he watches this video, could you consider that matter is actually just trapped light? That is my light love theory. It just takes your actual theory, or this theory of variable speed light, and takes it one step further and says that matter is light. So everything actually is light. Talk here, this is Einstein's 1930 draft theory. Okay, so by introducing a spatial variability of the quantity c.
That's also obvious from a talk in Switzerland in 1930. The speed of light is not a constant, and so on. If we are forced to generalize relativity, we have to put in question this principle of the constancy of the speed of light.
This is from 1913. So Einstein says the speed of light is not a constant. And this guy speaks German, so he can know. And quite interesting to me as a material scientist is if you look at dislocations. Dislocation is actually how matter bends. So a dislocation is actually how steel would bend. This is actually an edge dislocation, and this is a screw dislocation. And Unzicker has written a few papers actually on this, is how these move and how matter moves, right? How does matter actually bend? Is it moves these dislocations at the speed of light, is actually at the speed of transverse sound, which would be the speed of light. I mean, how can that be the same? How can that be the same? Okay, this is from Frank, 1949. What we've measured is longitudinal contraction by a factor of square root of 1 minus v squared over c squared, where c is the velocity of transverse sound. How can dislocations move at the speed of sound? This is through crystals. So this would actually link with quantum mechanics. This would link with quantum mechanics. If dislocations is actually how matter is actually interacting and moving throughout the universe, this looks like particles. And this would explain the double slit experiment, okay? Because these things can move through matter, okay? The matter does not break. This little break, okay? So what would happen is this dislocation here, when you bend this, it can move. This little box will move over to here. This dislocation can move actually and not even interact with each other. And this is how particles could actually be not particles, but dislocations, meaning the ether is real. So what would this mean is variable speed of light inside of an ether, which is a large crystal. The theory has been proven out over 100 years. All we have to do is actually look at it. You have to look at it. And to do that, you have to understand that your current theory is wrong. And obviously, our current theory is wrong. Okay, final points here. This is from Robert Dickey. Okay, he says this might be thought to cause a blue shift, is a net shift towards the red. So he, again, explains it, an alternate explanation of the cosmological red shift. He says it's not moving away from us. There's nothing actually expanding away. There is no dark matter. There is no dark energy. Okay, it's a misunderstanding. It is a big, big misunderstanding. And again, this was Einstein's theory. Variable speed of light was Einstein's theory before he got brain screwed by the mainstream science. And this always happens, okay? This always happens. This has always happened in history. We shouldn't be surprised by this. We should be surprised it's gone on for so long, for 97 years. We need people to have the courage to look at their assumptions. Okay, so I'm so excited to actually present this video to you. I hope you can find someone and shake them and shake an astrophysicist to get them out of their stupor. It's amazing how long do we have to consider? How long do we have to hearing that there's a crisis in cosmology? There is a crisis in cosmology. The problem is people don't have the courage to look into their assumptions and realize that they're wrong. The Hubble constant is not a freaking constant. It's obviously not a constant. Okay, things cannot grow that large based on the Big Bang. The Big Bang's been proven wrong many different ways. Okay, our current models don't work. But there are models, like Einstein suggested, variable speed of light. He also wasn't happy with quantum mechanics. If you look at quantum mechanics, the mess in quantum mechanics, that could also explain the baseline underlying assumption. And it could be related to this. Okay, if the universe is not expanding, if the speed of light is variable, that could also mean that our physics has been on purpose tampered with by those in the know. We've again, on this channel, we've looked at serious issues from the CIA and other organizations. David Grush even said that our astrophysics, astrobiology has been tampered with. Could it be tampered with for that long, for so many years? That's when our misunderstanding of the phenomenon came, right? Could it be related to this? Could it be related to this? That's why I'm so excited. Thank you for watching this video. Please hit the like button, share it with someone you think could benefit from it, which seems like could be many people. Hopefully you understood it. Check out those scientists that I mentioned. Links are in the description to their amazing YouTube channels. And that's how we'll get there, is using decentralized science. And it's going to come from us linking people like you, actually. People like you actually using your own brains, linking with other people, determining that our baseline assumptions are incorrect. If your assumption is wrong, it doesn't matter how smart you are, you will get to a wrong answer. It does not matter how smart you are. It takes courage, it takes integrity to go back and look at your baseline assumptions and admit that you're wrong when you're wrong. It takes all of us to admit that. It's hard. It hurts. It hurts a lot. But that's what it takes. And that's what integrity is about. Integrity first, everyone. We'll get there. We really will. Thanks again for watching. If you want to support me, support the channel, go to patreon.com/Chris Lato. I release other videos. And if you want to get access to the members only live stream, then you can become a YouTube member here on YouTube. Again, thanks for all your support. Have a great rest of your day. Peace.